going to go back in here. Okay, your index card, the first one, I'm going to write it here and then I'll move to what we need. On the first one, put blank property of equality. So on the front, write blank property of equality. There are 4 properties of equalities, and they're your 4 operations: add, subtract, multiply, and divide. So instead of making 4 separate index cards, you can put all 4 of these on one. So again, on the front, put blank property of equality, and then there are the 4 that are on the left side, so all of that will go on one index card. Distributive property, you guys probably already know, but you can put that on a separate index card, and substitution can be a separate index card as well. So right here's your first 3, index cards. And while you write those, I'm going to take roll. Did anybody else want lunch, by the way? I already asked y'all. So while you guys are finishing writing this, today is all about an introduction to proofs. So a proof is a way to prove that you are correct. How many of you have little brothers or sisters or cousins that come up to you and go, but why? But why? But why? Everybody's had that experience before. Everybody's been around some little kids who are like, yeah, but why? But why? That's basically what a proof is. Everybody doesn't like them. They're annoying. I'm going to go ahead and tell you that. But we've got to get through and prove why we're doing things or saying why we're doing it. Now, the reason why we talk about proofs and why we do it is a couple of different things. So, number one, it helps you to be a better math student if you can explain why. So, for example, if you're struggling with something, one of the recommendations that I give is go talk to your parents about it. Tell your parents what you learned in class, because if you can explain it to somebody else and they understand just a little bit of it, now your parents might glaze over and be like, oh God, I don't know what you're talking about. But it's a great way to help you understand what's going on if you can explain it. So that's why proofs are important for one reason. A second reason is a few of you put on your little info sheet that you wanted to do something that was related to science or to math. And when you go to college, you might have to take a class where you prove things, especially if you want to be a math teacher or an engineer. Now, will you have to do a whole lot of them? Probably not, but it's a good idea to see them and get used to them and what happens with them. And a third reason is because you want to be great communicators, right? And any job that you have, it's a good idea to be able to communicate like what you're trying to do or what you're doing in your job and different things like that. So it's a great idea to know how to communicate and do these things. So let's talk about our proofs. These are our properties that we're going to use to describe our proofs. So the addition property of equality is the first one. And all you're doing here is explaining what you do to solve for x. So if this was your equation, 3x minus 2 equals 9, what would you do to get x by itself? You would add 2, right? If you add 2 to both sides, you end up with 3x equals 11. That is your addition property of equality because we added the same number to both sides. So the equality part means that we kept the equation equal. Addition, we added. So what do we do for the subtraction property of equality? We minus 2 on both sides. What do we do for the multiplication property of equality? We're going to times by 4 on each side. That's exactly right. This is saying x divided by 4. So to get rid of the divide, we multiply. And the last one, what would you do to solve this equation? Divide by 5. If I divide both sides by 5, that is my division property of equality. So you use these words property of equality when you do the same thing to both sides. Now, we already solved equations, so you probably know your distributed property, right? Up here, we would distribute the 3. Y'all did great on solving equations on your quiz, a few little minor things here and there, but knowing that distributed property, you guys did fine on that on the homework too. And the last one we have is substitution. You guys did this back in Math 1. When you substitute, if A equals B, then you can replace B with A in any expression. So if you have 2 of the same things, they can replace each other and you have a different equation that you can write. Do those properties make sense? Okay, well, let's do our next slide. Here we have a table. So copy down everything that you see here. We're just going to write some things in this reason column. So write down all that stuff. Now, these are how proofs work. So all the work is on the left side. This is what we call a two-column proof. There are other proofs that we're going to talk about throughout the semester, but we're going to start with two-column proofs first. So two-column proofs, your statements are on the left, and your statements is all your work that you're going to do to solve. The reasons is on the right. So the reasons is your annoying little brother or sister who's saying why, but why, but why. So it first says at the top your instructions, and you always want to look at those because that's going to help you figure out where this word given should go. So it says given this equation. So notice that that same equation at the top is the same first statement that you have, right? And beside of that, we can put given. They gave that to us. So it's usually beside the word given, your statement, your reason, given. Okay, so now to find your next reason, you say, what happened from here to here? And that's where I put my reason. So what happened from this statement to this statement? Well, kind of just tell me what happened in words because it doesn't look like distributive property because I don't see things that are multiplied, but combined like terms. That is your reason. What was combined? The x. You can even put in parentheses if you want to what two terms were combined. They combined 2x and x to make 3x. Okay? Now, for the next reason, what happened from that statement to the next statement, and we put that reason here? Subtracted what? That's right. We did the subtraction property of equality. Now, you can shorthand property of equality because writing all that would probably get on your nerves about as bad as these proofs. So you can put prop of EQ if you want to, and then we know it's the property of equality. I had one person kept writing Poe, and I was like, what is Poe? And then I realized P-O-E, prop of equality. I was like, we're not talking about poems. You know, Edgar Allan Poe, you know. Anyway, okay. What did we do next to get from here to here? That's right. Divided by 3. Division, prop of EQ. And then that's it. So all you have to do is describe those things. What happened from the previous step to the step you're on. Okay. A big thing that people do is they put these in a different order. They move all of these up, but we want to keep it from what happened from the previous to the next one, and that's where your answer goes. Does that make sense? Y'all feel like y'all can do this? Not too bad, right? Okay. Last index card, I believe. All 3 of these put on the front and then put what they are on the back. So reflexive, symmetric, and transitive properties on the front, and then put your 3 statements on the back. Save a line between them if you can, because we may write some extra things beside of them, beside each one. Now, reflexive, symmetric, transitive. How I remember RST 1, 2, 3. Kind of similar to point, line, and plane. How we have 1 letter for point, 2 letters for lines, 3 letters for planes. These 3 are kind of the same. Reflexive deals with one thing. When I think about reflective, I think about reflection. So when you look in the mirror, you see the same thing, right? So that's how I remember reflexive property. You will see a lot of the reflexive property when we talk about triangles, especially when we look at Math 3. But it's kind of redundant. AB equals AB. The same thing equals the same thing. There's one item there. AB equals AB. Symmetric property is kind of like a line of symmetry through here. A line of symmetry kind of reverses that order. So if you think about if we had maybe a triangle here, then that's going to flip over this line, and that looks terrible. But imagine they look the same. It's just a line of symmetry that's reflected. Okay? So AB equals BA. Because does it matter how we write a line segment? AB is the same as BA, right? So these are the same things. They're just reversed order. Transitive property is very similar to substitution. Except with the transitive property, we deal with 3 things. So in the transitive property says, if AB equals CD and CD equals EF, then AB is equal to EF. Kind of like CD's in the middle. CD's kind of the buffer. You know, it's kind of like if you got 3 friends. These 2 friends are equal. Not equal. These 2 are friends. And these 2 are also friends. So by default, you're friends with that friend. Because we all are friends, not bullies. So there's our properties. All right, we are going to do another proof next, but you guys do not have to write this down. I copied it for you because I figured that was a lot of work. So let me pass this out real quick so that way you guys can have it. Here you go. Just take one, pass it around in your group. You're going to have more left over, and I will come back and get the extras. There you go. Pass that around. 1, 2, 3, 4. Pass those around. There you go. Look, pass those around. Y'all have just enough? Good. I know. Who knew math was so much writing, huh? All right. Now, this one is more of a geometric proof. So the last one that we did was more of an algebraic proof. We were explaining our algebra steps, but this is more of a geometric proof. So the first thing that I like to do is I like to look at what is given. We are given angle 1 is equal to angle 3. Do you see that written anywhere down here in your proof? Yeah, it's the first statement, right? Angle 1 is equal to angle 3. Is it exactly the same? Then first reason is a given. If they are exactly the same, then you can write it down as given. We are given this information. Okay? Also, notice that they're marked in the picture with our little curves. Angle 1 and angle 3 are marked with the curves, which means that they're congruent or they're equal to each other. Now, let's look at our next statement. Sometimes we have to just roll through these statements. Angle 2 is equal to angle 2. That's actually one of the properties we just wrote down. Which one is it? It's the reflexive because it's the same thing equals the same thing. So for statement 2, this is our reflexive property. Now, up on the board, it's kind of in red, and I think on y'all's paper, although it's printed black and white, it does look like it's a little lighter than the other. So what happened to get this statement? Now, this one's kind of hard to see, but if you look at this statement above, we have angle 1 equals angle 3. So here's angle 1 equals angle 3, but now we have angle 2 added on both sides. So what's it called when you add the same thing on both sides? We did it before on this one. It's the addition property of equality. Yep. And again, that one is pretty hard to see, but if you think about what's different, is there's that added angle 2 on both sides. So we added the same thing on both sides. So anytime you do that, it's the addition property of equality. Now, problem 4, statement 4, looks a little bit different. Sometimes you have to look at your picture. It's saying if you add angle 1 and 2 together, you get angle AEC. Well, angle 1 and 2 are in that angle AEC, right? So we're adding up 2 angles to make a whole angle. We're doing a part plus a part equals a whole. Now, since we had all these snow days, it's been a long time since we used those phrases, but that is our angle addition postulate. And I know we have that down on an index card. We have our segment addition and angle addition postulate. When you add 2 angles together, you get the whole angle. Now notice it says the same thing, and I didn't write this down, but it says if you add angle 3 and angle 2 together, you get angle DEB. So if I were to trace out from D to E to B, that's this whole angle, which is made up of angles 2 and 3. Now, our last reason, or our last statement, is always what we want to prove. So if you notice up here, what we want to prove is always going for the last. It's not letting me draw a line. Imagine that connects. It does not. Oh, there it goes. It's always that last statement. But the last reason is never prove. You can't write the word prove in your proof. You have to say, why is that true? So if I'm going from here to here, how can I use all of this info to get this? So let's look for things that are similar. Angle 1 plus angle 2 is also written right here, right? And angle 3 plus 2 is written here. Now, angle 1 and angle 2, if we add those up, it also equals angle AEC. So this part can be replaced with AEC. And if you do that, you get this last part here on the left. And then this part, angle 2 and 3, can be replaced with angle DEB, which is this part. So we replace something, and when you replace, what's another word for replacement? Look back on your index cards that you wrote. One of those say something about replace. I think somebody's saying it, but you're not saying it loud enough. Substitution. That is it. So if you add 2 things and they equal something, you can replace that together. So that is our substitution property. All right, let's do the next one on our sheet. The next one is a lot shorter, so you might be able to get this one a little bit easier. But use this as a guide when you do your homework. See if there's similar things in there that happen. All right, so here's our last one. We have another picture, and it says angle 1 and angle 2 are supplementary, and then I spelled supplementary wrong. Let's pretend like this is an N. I really wish this board had spell check, but it does not. That's okay. But let's say that was given. So now we have in statement 2, angle 1 plus angle 2 equals 180. Well, why can we say that they add to equal 180? Because they're supplementary, right? Things that are supplementary add to equal 180. So for number 2, this is actually the definition of supplementary. If you say that things are supplementary, then you can add them to make 180. Now, what happened from statement 2 to statement 3? I went from angles to 3x plus 2 plus 4x. How did I go from there to there? Substitution. I substituted in what my angles were. Angle 1 is 3x plus 2, and angle 2 is 4x. So I made a substitution. I cannot spell today. Let's try that again. Substitution. Helps if you sing it, right? Could we finish up this proof? Because I bet that's not the end. What would you do next if you were solving this? Combine like terms. Let's finish up this proof and add some more statements. So statement 4 over here would be what? We could combine like terms and get 7x plus 2 equals 180. So statement 4 would be combine like terms. I think it's much easier to do the algebra part of this and keep solving, right? What would you do next? You'd get rid of that 2, right? Subtract 2. So in statement 5, we would have 7x equals 178. And what is the reason? Subtraction property of equality. Okay, we need one more. So 6 would be to divide. So let's use our calculators to divide that. 178 divided by 7. Now we're going to have to just round on this one. We're just going to round to one decimal place because it doesn't give us a lot of stuff. So let's say x is about 25.43. And the reason over here is division property of equality. If you notice the handout that I gave you, there's actually one more problem on the back, but we are not going to do that one today. We're going to do that tomorrow. So just ignore that, but save this paper. Don't lose it. So this is part of your notes. Keep this paper out too, because what you guys are going to do next is this homework. Just ignore the rest of this stuff because that was from last year. So I want you to find page 156 and I want you to work together. Now, how do you work together if you're in a group? You talk, and that's number 1. Yep, what else? Well, talking is the most important. Compare answers with each other. Stick together and do one problem at a time. You guys got almost 45 minutes, so you have time where you could probably finish this even with your group. Now, this is part of your homework, so everybody's doing it individually. When you finish a problem, what would be a good idea to do? Check with Miss Cook or check the answer key. That's the right answer. So why don't you make sure that you get the first 3 done? The first 3 are just one property, but then after that, some of these have multiple parts. So when you finish a problem, raise your hand, call me over, and I will check. But your goal is to work in groups and talk about it. You could even take turns, go around the circle. Like Melanie could do number 1, Alex number 2, and keep going, You know what I mean? We'll see how this goes. Yay, group work. All right. If you're watching this video at home, just do it all on your own. But you can always take a picture and send me your answers, and I will check them. Have a great day.